Hey guys, welcome back to solving exponential functions. This is day 2. We're going to look at how to get the bases to be the same and if we have exponentials on both sides. Real quick, let's just try an example from day 1. If you want to pause it right now and try this example on your own, then you can play it and see what the answer is after that. So if we want to solve this exponential from day 1, remember we need to isolate this exponential first. So we're going to isolate this. So first thing we need to do is add 4 to both sides. We get 2 times the exponential 3 to the x equals 10. Divide both sides by 2. Then we're going to log with that same base. Log base 3 of both sides. And that's going to give us x equals log base 3 of 5. Again, remember, that's your solution you could get. That's the exact answer. That's what you'd get if you have no calculator. If you're plugging that into the calculator, you're getting 1.465. Now, what we're going to look at today is this type of example here. Okay, when we have this exponential on both sides of the equation. And so what we're really going to look at is we're going to look at these bases, and we're going to see how these bases are similar and how we can rewrite this 9 here using this base of 3. So remember, we're looking at how to solve exponentials. Remember, in order to do that, we use the inverse of an exponential, which is a log. And so for today, what we're going to do is we're going to make the bases similar. Okay. So steps to doing this. This is the second type of exponential that we're going to solve. So we have 2 exponentials, one on both sides, and what we're going to do is we're going to try making the bases the same. And so in order to do that, you're going to try making the bases some small number. Okay, so you're going to try making both bases 2, make both bases 3, make both bases 4, and so on. Okay, once we do that, then we're going to do the same thing we did day 1 and log both sides. So if you look at this first example, you should be able to look at this and know what this answer is. Okay, we can see that 3 to some power equals 3 to the 4th power. Well, in order for these to be equal to each other, x is going to have to equal 4. Well, we talked about the other day, once we get this, we can take log base 3 to get rid of this 3 on this side. And then we do the same thing over here. Log base 3 of 3 to the 4th. Well, what's going to happen then is these log base 3, exponential base 3, log base 3, exponential base 3 are both going to cancel each other out, and we're just left with x equals 4, just like we just said. Okay, now the difference here is when these bases are not the same. So now I have a harder time just looking at this and deciding what they equal. So what we're going to do to get it to look like example number 1, where we had base 3 and base 3, is we're going to have to manipulate this to make both of these bases the same. So this one's already base 2. It's already small. So what we're going to do is we're going to rewrite this second one so that it has base 2. So I'm just going to rewrite 4 as base 2 squared. Now, remember our exponent rules. Our exponent rules tell us that if we take power to a power, that is simply multiplication. So it becomes 2 to the 2x. Now, just like we did over here, I can now just take and log with base 2 of each side. And what's going to happen is these log base 2's are going to cancel out. And it's going to leave us with what we wanted, this simple linear equation. And so once we get here, we can easily tell, we can easily solve this. It's just a linear. And so I'm going to subtract 2x. I'm going to add 4. And we're going to get this solution here. Okay. Now, notice here, when I have the same base and I log both sides, all that it's really going to leave me with is our exponents. 3x minus 4 equals 2x. And so what we're doing is we're logging both sides so that we can use our inverse and cancel those out. But really this step right here is going to give us the same thing every single time. It's going to go from here to here. And so these bases are going to cancel. And it's going to leave us with the exponents. So really, I'm going to continue to write this step. Okay, but you can kind of skip this step. So let's look at the next one. So again, I want to make these bases both the same thing. And so again, you're using numbers like 2, 3, 4, 5, these smaller numbers to rewrite these. And so if I want to rewrite 1/3 as just a number like 3, well, we know 3 to the negative first is equal to 1/3. 3 to the negative first is 1/3. It's just we wrote it in a different way. Same thing here. I can rewrite 27 as simply 3 cubed. Now from there, we're going to use our power to a power rule. So 3 to the negative 2x, because we're multiplying these powers. 3 distribute, because you're multiplying, so 3x plus plus 3. And so now again, this step where we log both sides, so we're going to log base 3 of 3 to negative 2x, log base 3 of 3 to the 3x plus 3. And so when we do that, again, it's just going to cancel everything out and leave us with just these exponents. And so it's going to leave me with negative 2x equals 3x plus 3. And from there, it's just a linear again. And so again, we're just going to solve. And so we're going to get 5x equals negative 3. And so x equals, we're going to divide by 5. So negative 3/5. Okay, and so this step again here in the blue, it's the mathematical way that we're solving this, but again, you can kind of skip it and go straight to having, once you have the same base, exponent equals exponent. Okay, all right, I want you guys to, on your own, go ahead and try these 3 examples. So pause the video, try those 3 examples, and then once you hit play, those answers will be on the screen. All right, guys, here's your 3 answers. Go ahead and check your work. Make sure you got the correct answers and proceed on to your practice problems.